Nathan describes himself as an operations and business-focused engineering leader. He is currently Director of Facilities, Reliability and Integrity of TC Energy's Canadian natural gas assets. He has over 16 years of oil and gas experience, with 4 of those being with TC Energy across both its liquids and Canada gas business units. Nathan started with TC Energy as a manager, a liquids mechanical engineer, and has held roles of increasing responsibility, with his most recent being Director, Canada Gas Operations Reliability. Prior to his time with TC Energy, Nathan worked at Devon, Canada, in SHED operations and engineering. He holds a Bachelor's of Engineering degree from the University of Saskatchewan. I think I pronounced that right. And Nathan, I'll hand over to you.
Thanks. Well, I thank you for the introduction, Jasmine. I really appreciate that. I guess I don't need to introduce myself since you did that. So today we're going to chat a little bit about, I guess, an example of what Jasmine was talking about in her kind of best practices. I actually mentioned a few different examples there, but we're going to talk about mitigating specifically our blowdowns in our pipelines. And it's quite a large vented methane emissions. So we'll talk a little more about that. If you can skip to the next slide, please. There we go. So the main issue here is obviously, if you worked in facilities or pipelines, pipelines have long stretches of pipe that are between block valves. And when you go to do any maintenance or repairs or whatever it might be, add, like Jasmine mentioned, add a branch to a section to tie in something, you tend to have large volumes of methane you have to deal with. In a facility, sometimes it's smaller, it's a little bit easier, it's less impactful, but for us, it's quite massive. And to manage that gas, there's a couple different ways, and we want to talk about a few. But initially, we've actually been using this transfer compressor you see on this picture here, which is a full-on compressor station, effectively on wheels. We drag that in and actually take the gas that's in the existing section that's isolated, that pipeline that's isolated, and transfer it to an operating section. That's been happening for years and years and years, and it's not new to us. And it does a great job. It moves gas very quickly in large amounts of it. The trouble, and the reason we're talking today, is that only gets us down to about 25% of the volume that was in that pipe. And that 25% is still quite a vast amount of methane because of the size of the pipelines and the lengths that we're talking about. So the question really is, how do we deal with that residual gas, and where do we put it, right? And what do we do with it? And there's many different options we've been looking at today, and we're going to go to one of our key pieces here. Before I get to that though, this last 25% is obviously, like it says on here, is one of our key opportunities for reducing our emissions as TC by that 30% by 2030. So if you can jump to the next slide, we'll talk about more of the solution here. So incineration is one of the solutions we want to talk about. Actually, Jasmine, I think I saw your slides. It didn't actually mention incineration, and you had flaring, which is intriguing. Because flaring, if you've ever dealt with flaring, I've done it at the facilities, I've done it a little bit out there, but flaring is a little bit less efficient than incineration, right? So incineration has been around for a long time. This isn't a new technology, this is more of a new application for TC. What it does is effectively, we are able to connect to that pipe that has that remaining 25% residual gas and basically destroy it through burning. The reason you do incineration over flaring is that these are purpose-built to, I guess, have very high combustion efficiencies. I think you see 98% it says plus on these. So what that means is you have very little methane slip. So with a flare, especially at some of the plants, things that are designed there just to basically deal with an overpressure situation or other things like that, you tend to have a lot of methane slip and you lose a lot of it to the environment. In this case, these are purpose-built to combust very, very efficiently. So for us, like I said, we're trying to deal with that last 25%, and this works. This is quite a good tool, not new technology, so we know how to use it. It's readily available, and we can deploy it on our systems. The issue with this technology for this application is, and probably the one big thing, is the time to actually combust that gas. As you can imagine, the transfer compressor is quite fast. It does a really good job of moving a lot of volume at kind of lower DPs, right? That's why it can only get us to 25%, where that suction pressure drops to a point where you can't manage anymore. But once you get down to those lower pressures, it takes you longer and longer to obviously deal with it. And that's one of our big concerns. And then, of course, if you know much about TC, so we have natural gas infrastructure across North America. and we have a lot of critical clients. And so time for outages is of the utmost importance in a lot of cases, be it for industrial users or maybe our the houses and everybody else that uses natural gas. So that is one thing we have to manage. But of course, with planning, you can get around a lot of those things. So that's been quite well. And that gets us to our examples. As you can see on the right there, in the last couple of years, we've actually been able to execute 6 of these events where you would have used the transfer compressor and then brought on the incinerators. And each of those 6 events, those pilots, we were able to reduce the methane emissions by about 1,000 tons of CO2e per event. The one you see there is actually 2,000 plus, so it depends on the length of the pipeline and diameter, of course. And then if you have the time to actually do that activity without affecting our customers. So really effective solution with some downsides is what I would say here. He does a really good job of burning the gas. It takes a lot longer though for us, so you have to manage it. You can jump to the next slide, please. Thank you. So yeah, in conclusion, this is like absolutely a tool in our toolbox, and it absolutely should be. The big disadvantage, like I mentioned, is the time, and that kind of leads us to what are the other options that we might have. Like we continue to look at other options, and Jasmine, you mentioned a few of them. One of the other things that we're looking at is a secondary transfer compressor, something smaller that can manage that higher DP at a little bit lower rates and conserve the gas, which is of course the best case scenario. Bypasses, hot taps that you mentioned is another one that we're really looking at. And then third, my favorite one, if you've ran facilities, is just reduce outages. How do we get creative with the work we're doing? How do we bundle it differently? How do we do things like that to actually just avoid the need to actually blow down these pipelines? That's always going on, and absolutely will continue to do that. So finally, like I said, in closing, incineration is like absolutely something we're going to use. It's going to be a tool in our toolbox. It's definitely going to support our goals for meeting our regulatory requirements in Canada. It's going to support reducing our costs for our customers, and it's definitely a great tool. And in addition to that, we're going to keep looking at other technologies, and as we learn more, we'll share them with you folks.